less than 10 seconds.
Hey everyone, Michael here from the MacMillan Space Center, once again joined by the incomparable Morgan from Let's Talk Science. Let's talk with Morgan. How's it going, Morgan?
I'm doing well. How are you?
It's a really interesting time of year. We are getting to the end of the school year. We are getting to the end of a season, which is actually what we are talking about. This week, we are talking about the solstice.
The summer solstice, no less. There are two solstices per year, summer and winter, of course, and those are divided by the equinoxes. And I was hoping that you could sort of talk about what the difference between those two things are for us.
Yeah, of course. So we have sort of like these four markers of time. Now, there's many ways that humans have sort of divided their time. We live with a Gregorian calendar. We have months of the year, but of course, different cultures, all around the world have also had their ways of marking time. Now, if you're just looking at our planet, if you were an alien kind of like looking at our planet, and we do this with lots of other planets in the solar system, we can sort of look at it, when it comes to the orbit. So of course, our planet goes around our sun once. That is a marker of 1 year. But as we are making this this little travel route, our planet is not straight up and down. Of course, it is on this tilt. So for places like us, here we are in North America. We sometimes are tilted away from the sun, and sometimes we are tilted towards. Same thing for South America, for Australia. People that live along the equator, though, interestingly enough, as our planet sort of like tilts back and forth, they don't really get, the seasons that we do, which I find really interesting. Like living in Canada, we get very used to, snow in the wintertime, rain in the springtime, nice weather, hot weather in the summertime, and then leaves falling in the fall. But that's not the case for all the other places in the world. So, those markers, when we're tilted most towards the sun, which is what's going to happen on summer solstice, that is the longest day of the year for us in North America. And as we make that journey around the sun, we're slowly actually tilting away until eventually we'll get to a place where we're kind of equal. The southern hemisphere and the northern hemisphere have equal day and equal night, and we call that the equinox. And those happen, the fall equinox, the autumnal equinox, as it's called, is in September, and the spring or the vernal equinox happens usually in March.
Yes, nice. And so it's not actually like that the Earth is tilting, it's just that the tilt is being affected by our orbit around the sun.
Correct, yeah. So it's not like, we're not really tilting back and forth. It's kind of like as we go around the sun. So say, for instance, let me get here. Here in North America, we are tilted towards the sun, but then we're going to make a real path around. And then now, as we spin around for the day, we are now tilted away. I'm trying to see if our camera can see there.
No, that was good. That was good.
These nice squishy earths that are also doubling as my pillows because I'm working from home these days. So.
Interesting.
So what activity do you have for us this week?
So yeah, we're going to learn a little bit more about that and how the Earth's orbit around the sun really influences how we feel seasons in different parts of the world. And again, like you said, we get 4 seasons here in North America. Places around the equator have more of a mild kind of 1 or maybe 2 seasons sort of feel to them. And we talk about how that impacts society in different ways. You hear people saying all the time, I don't want to leave Vancouver because we get the 4 seasons, and so on and so forth. And we even discuss a little bit about the North Pole and how it can have 24 hours of sunlight, but not be the hottest place on Earth.
I've never traveled up there. I've always wanted to go. I have family that live up in the Yukon. They always talk about, this time of year around sort of like the solstice when they get that sort of like 24-hour daylight. It seems so cool. I'm going to make the trip up there. I promise, family, if you're watching this up there in the Yukon. For everyone out there watching this video, we actually are going to be doing program on site on June 20th on the solstice. So check our website. You can get tickets there. We got some really fun outdoor programming that we're going to be doing. Super excited to get back and hopefully see some people. So for me, from my kitchen, Morgan, let's get to this week's activity.
Let's do it. Enjoy, everybody.
Hi everyone! I'm so glad you're tuning in today to learn about the reasons for the seasons with us. We are going to be doing a fun science experiment to explore something called the axial tilt of the Earth and how this influences the seasons or the temperature and conditions in our climate as Earth makes its orbit around the sun over the period of a year. Where most people live on Earth, summers are hot and filled with many hours of strong sunlight, while winters are cold due to shortened hours of daylight and weak sunlight. You might think that the extreme heat of summer and the icy cold of winter have something to do with how close Earth is to the sun. But actually, Earth's orbit is almost circular around the sun. So there is very little difference in the distance from Earth to the sun throughout the year. So what are the reasons for the seasons, if it's not distance from the sun? Well, I kind of spoiled it already. But one big part of the answer is that Earth is tilted on an axis. What is an axis? Picture an imaginary stick going through the north and south poles of Earth. Earth makes a complete rotation about this stick, or axis, every 24 hours. However, this axis is not straight up and down as Earth goes through its orbit about the sun. Instead, it's tilted approximately 23 degrees. How does the tilt of the axis create the seasons? The tilt changes how the sunlight hits Earth at a given location. Earth's axis remains fixed in space. It always points in the same direction, as Earth goes through its orbit around the sun. When it is summer in North America, the North Pole points in the direction of the sun, and the sun's rays shine directly on us. While in South America, the axis is tipped away from the sun, and the sun's rays hit Earth on a slant. So when it is summer in North America, it is winter in South America. When it is winter in North America, the North Pole is tipped away from the sun, and the sun's rays hit the Earth on a slant here, meaning it is summer in South America, because the sun's rays hit Earth more directly in that hemisphere. As for the intermediate seasons, spring and fall, these are when neither the top or the bottom of Earth's axis are pointed in the direction of the sun. Days and nights are more equal in length, and both the top half and the bottom half of Earth get about equal amounts of light. Slanted rays are weaker rays because they cover a larger area and heat the air and surface less than direct rays do. You can see this if you shine a flashlight on a ball. If you point the flashlight directly at the ball, you see that there is a concentration of light in a small area. As soon as you tilt the ball away from the flashlight, the light covers a larger area. This is similar to how the light's ray from the sun might affect Earth's warming according to the axial tilt of the Earth at any given time. In our experiment today, you will investigate how tilting a surface affects the light rays from the sun as they hit the Earth. The first thing we need to do for our experiment today is collect our materials at our workbench. You're going to need some Scotch tape, a shoebox or other small box about the same size. You could also use a stepping stool or maybe a big book. You're going to need a flashlight, which will be our sun's rays for today, some graphing paper, as well as another big surface, a book or a box or a cutting board, to tape your graph paper to in order to make it sturdy enough to stand on its own. So, once you've collected your materials at your bench, you're going to take your flashlight and tape it to the top of the box so that it can't move around. Once you've secured your flashlight to the box, you're going to also tape your graph paper to the top or to your surface. And now you're going to stand your graph paper so that it faces your light source. You want to test that your graph paper is at a good distance from the light source just by turning on the flashlight. And having the flashlight far enough away that you've got about 5 lines of graph paper free above the light as it's hitting the graph paper. Now, we're going to take our first measurement. So in our lab notebook, we are going to write the number of circles or squares that are covered by light at this angle of tilt. So we haven't actually tilted our surface with the graph paper on it at all. Therefore, this angle of tilt is 0 degrees. And there are approximately 153 squares that are illuminated by our light source at this angle. Now, with the help of a parent, you're going to tilt your graph paper approximately 10 degrees away from the light source. It is really important that you don't change the distance of the light source from the graph paper here. You just tilt it backward, about 10 degrees. You can use a protractor to make this measurement more precise, or you can approximate based on the figure that is given in the PDF instructables attached to this video. So then you're going to repeat your measurement. You're simply going to count the number of squares that are illuminated by the light source at this angle of tilt. For my own personal measurements, I've counted 153 squares that are illuminated at 0 degrees, 172 squares that are illuminated at 10 degrees, and I'm going to repeat these measurements at 20 degrees, 30 degrees, and 40 degrees. You'll notice that at the 40-degree measurement, I have written down TNTC. This is an abbreviation that we sometimes use in microbiology when we have too many bacteria to count. And so it literally stands for too numerous to count. When I tilted my paper 40 degrees away from the light source, the light actually exceeded the area of the graph paper, so I was not able to count. Now you might notice that as we increased the degree of tilt of the graph paper from our light source, we increased the number of squares that were illuminated by the light, and this really demonstrates that the greater the tilt of the Earth's surface away from the sun as it orbits about the sun over the period of a year, the broader the area being illuminated by the sun, and the less energy, the less intense energy is being felt on the Earth's surface. Now, interestingly, we can go further with this. We can start to talk about the length of the days throughout the year and the heat on the Earth's surface at different places on Earth throughout the year. Anybody 40 degrees or more north of the equator will experience approximately 15 hours of sunlight and 9 hours of nighttime on the summer solstice, which is the longest day of the year. It's coming up for us on June 20th, 2020. Also happens to be the same weekend of Father's Day. It's just a big weekend of celebration. So on that day, again, we might feel something like 15 hours of sunlight and 9 hours of night. The days will proceed to get shorter from this point on until the winter solstice, which occurs in December. Now, other places in the world more north of where we are might feel a longer day. So somewhere like the North Pole, as the most extreme example, will have 24 hours of sunlight on this day, which might make you ask yourself, if the North Pole is having 24 hours of sunlight all for about a week or so around the summer solstice, why doesn't it get so hot that all of the ice at the North Pole melts? It's something for you to research further and maybe post in the comments below what you find out about that. As well, you can look at places in the southern hemisphere. So on our summer solstice, are they experiencing summer? Ask yourself what kind of question or what kind of conditions they might be feeling there. Go and research them and let us know what you find out. With that, I will let you guys go and play. Again, thank you so much for tuning in. We look forward to seeing you next week.